Welcome everyone to today's webcast, sponsored by Pluribus Networks and Broadcom, Innovations in Open Networking and SDN. Today's webinar is going to be primarily focused on the data center with a look towards scaling and automating data center networks in particular. I wanted to welcome everyone, and I hope everyone is out there staying safe and healthy in these very strange times. Before I get started into the main webinar, I wanted to talk about a few housekeeping items. So all attendees are automatically muted during the webinar. That means if you want to ask a question, you need to go into your widget under the question tab and submit it. Submit any question you want. You can see there's a little visualization of it over to the right. Questions of the webinar. And we're also going to record the webinar, and tomorrow we will email a recording of the webinar and a link to slides so you can review it at your leisure. With that, I'd like to introduce our panelists. So today I have joining me from Broadcom, Balaji, who's a Director of Marketing. Welcome, Balaji.
Thank you.
And our very own Alessandro Barbieri, VP of Product Management from Pluribus Networks. Thanks for joining, Alessandro.
Thank you, Mike.
And I'll be your host and initial panelist today, Mike Capuano, Chief Marketing Officer here at Pluribus. So the agenda is pretty simple. I'm going to take the first section. I'm going to be talking about some market trends in data centers, open networking, and SDN. And I'm going to hand it off to Balaji, who's going to be talking about networking hardware innovations in the white box and bare metal sector. And then turn it over to Alessandro, who will take us through some innovations in software around network operating systems and SDN. And then I'll wrap it up and we'll go into a Q&A. We should have about 10 minutes for a Q&A at the end, so please do submit your questions. With that, let's get started. So this is an interesting chart from IDC, and I think we all have heard a lot of buzz about public cloud, and there's no doubt that public cloud is growing. But I personally find it very eye-opening to look at this chart and to really look at the data. And what you see when you look at this chart, especially as we're moving towards the ideal state, this is a state of where IDC interviewed a bunch of folks, enterprises, service providers, and said, what is your ideal state? That a large number of the workloads, in fact, about 75% of the workloads are remaining, I'll say, quote, on-prem, either in a private cloud, hosted on-prem, hosted at a hosting company, or in sort of regular data center infrastructure. And what, for sure, these data centers need to become virtualized and automated. They need to have the characteristics that the public cloud has to offer, become software-defined data centers, including the network. And I think the reason that we're seeing these kind of numbers is that a lot of folks are realizing that there is a set of parameters that says, this workload makes sense in the public cloud, this one makes sense on-prem or in the colo. So I think we're seeing a maturing model and framework around that in decision making. Here's another interesting set of data from IDC. So on the left-hand side, you can kind of see that this data backs up the previous slide. Which of the following does your organization utilize? Multiple data centers that you own or lease, managed hosting services, co-location space are all sort of at the top. At the bottom is single data centers that you own or lease. We definitely know that many enterprises and non-service provider type of operators are moving away from owning their own facilities, but that doesn't mean they're moving everything to public cloud. It means they're just moving away from owning the building and moving to shared infrastructure. The other interesting trend we see is in this chart, where the blue is kind of today or a year ago, and the orange is where folks are headed. That each institution that was interviewed as part of this survey is basically saying, I'm going to deploy more data centers. So the most pronounced decrease was those who own 2 or 3 or leverage 2 or 3 data centers, and the increase is in I'm going to own 4 to 9, or I'm going to use 4 to 9, I'm going to use 10 to 19. So we can see this increase in more data centers, more distributed, making the network even more important. So when you look at it, you know, you've got these on-prem colo type data centers. They need to be automated. They need to be virtualized. And you look at what's been achieved so far. Compute and storage, software control, virtualization has progressed dramatically. VMs and containers are pretty pervasive. They're delivering agility. You know, VMs are sort of the stalwart. Containers are emerging, but there's no question that software control and virtualization of the compute and storage infrastructure has made great progress. The network is still not quite there from a deployment perspective. It's many data center networks are still complex to operate. Many IT teams who are looking for solutions to virtualize the network are finding that software control, the underlay and virtualized overlay is elusive, it's expensive, it's complex. The ROI is not always clear, and it can be an impediment. And what we want to talk about today is solutions that are available to solve this problem that can work out of the box based on open networking and white box. So when we take a look at open networking, here's a chart from IHS Markit that kind of shows on the right-hand side the growth of different types of switch categories in the data center. The blue line up top is purpose-built. That means, you know, a data center switch from a Cisco or a Juniper, a vertically integrated type vendor. It's growing, but the fastest growing switch category is the orange line. That's bare metal. 46% year over year, with a forecast of 31% of ports shipped by calendar year 23. Now, obviously, there's a lot of room. The vertically integrated vendors still dominate, but I think this shows that there's tremendous growth and that open networking, bare metal switches are running in high-scale production networks with maturity, reliability that folks need, and more enterprises are looking to this to kind of ride the coattails of the hyperscalers and take advantage of cost savings. Today is primarily 10 gig, 2500 gig, 400 gig is out there. Obviously, it's coming. I'd say it's not widely deployed today because the optics are still very expensive. The other interesting points are the open networking switch ecosystem is expanding. More and more enterprises are deploying it. And the mature available options for switch OSs, like what Pluribus offers, continues to improve. So the whole market is just really maturing and growing, and we're super excited about that. From an SDN perspective, this is some data from ESG Research. They did an analysis of companies that had digitally transformed, had completed their digital transformation, which is, you know, it's not a huge number of companies that have achieved that yet, but a number of them have. 97% of those that transformed are committed to SDN, so I found that pretty interesting. Those who had deployed SDN were able to deploy applications 2 times ahead of schedule, and those with SDN are able to beat their competitors when they measured sort of return on investment, profitability, by 3.5 times more likely to beat their competitors to market. So that is some of the market data we see out there. We're pretty excited about what's going on in open networking and SDN, and I'd like to now turn it over to some experts who can take us through some more detail. So first I'd like to invite Balaji from Broadcom to go ahead and take control and talk about innovations in open networking hardware.
Okay, very good. So good morning, everybody. And as Mike introduced me, I'm Balaji from Broadcom. I'm part of the marketing team here. So in my section, let me introduce you to the capabilities of Broadcom Ethernet switch silicon and what you can do with it. So there are 3 distinct class of markets with differing needs, which we address with our 3 product lines that you see here. And customers are able to offer depth and breadth of products from the Broadcom portfolio based on their focus market segments. So hyperscalers with their very large layer 3 IP networks demand the highest bandwidth and deep telemetry. We address this customer base using the Speedbuster Tomahawk product line. 25.6 terabit per second Tomahawk 4, which is sampling now, is a perfect example of that. Then you have a very large customer base that needs all kinds of functionalities, such as some building layer 2 networks with virtualization using provider bridging and that kind of technology, and some that in this segment that use layer 2 VXLAN tunneling over layer 3 networks and then stitch them seamlessly using software-defined networking primitives, as you will see in the future slides from Pluribus. And some like telcos in this space that need MPLS traffic to enter and exit the data center network while processing the encapsulated packets in an NFV cluster. We have seen versatile, Trident switches being heavily used here, and especially because the Trident class of switches are programmable, customers are able to leverage their investment, over a long period of time. Okay, then you have the customer base that needs sophisticated traffic management across hundreds and thousands of queues, millions of routes, needs over 10 level of MPLS stack, and a very deep packet buffer, such as 8 gigabytes of packet buffer and targeted for aggregation networks. So Jericho 2 is an example of a product that is part of this product line and is very attractive to the customer base that you see here. So in all, we are covering the 3 market segments, which are very large, and we address with the 3 set of products that we have here. And as you can see, the needs are very, very wide between the 3 market segments, and nobody can just service them with a single product. Okay, so in this particular slide, we are focusing on the key part of how Broadcom delivers its products. So we are in the business of building the plumbing infrastructure of the knowledge-based economy. The world's largest compute infrastructure run on Broadcom switching products, and we take it very seriously. So execution is front and center of the Broadcom switching business. So innovations are created and put to use for the right applications that our customers value, such as getting to 7 nanometer on the 12.8 terabit per second Trident 4 and 25.6 terabit per second Tomahawk 4 switches to offer the highest port density and bandwidth together with the required functionality, or launching NPL-based programming on Trident 4 and Jericho 2 switch silicon. Our customers rely on Broadcom execution to give them new, higher bandwidth, more capable products generation after generation with consistent software APIs for time to market. That's really the key there. This effort of ours in innovation and execution fuels building up of standard compliant hardware ecosystem consisting of white boxes and complex OEM modular platforms such as the 8, 12, and 16 slot chassis. Companies such as Pluribus are providing disaggregated high-quality network operating systems to support software-defined networking on virtualized network. And we are always happy to be in this cycle working together with our ecosystem partners as we deliver products year after year. Let me show you how in 3 steps a white box switch is built or selected and brought to the market. So white box switch is essentially a switch or a router hardware platform that supports disaggregated operating system supporting a wide variety of services such as SDN framework, etc. So the first step is really to select the right switch silicon that fits the requirement, such as switching bandwidth of 3.2 terabit per second or 12.8 terabit per second. Number of ports and port bandwidth. For example, you can choose the 32 ports of 100 gig or 64 ports of 400 gig. So these are all available in the Broadcom portfolio. Similarly, you can pick silicon that supports virtualization, IP table scales that you need if you need millions of routes, like 4 million routes, 3 million routes, access control lists, and advanced telemetry applications. You have to pick the right silicon. And with the right silicon comes the default set of switch silicon API that you see in the picture as well. The second step is to use the chosen silicon to build a white box hardware, or choose from the hardware platform available from the hardware vendors or the ODM community. Broadcom works closely with all of them. This example shows that Trident 3 switch has been picked up to build the white box hardware platform. The third step is to pick up the disaggregated network operating system that fits your requirements of software-defined networking, while providing the management layer for all the key features exposed by the underlying switch silicon. And with this, you essentially have a switching solution that you need for your network in just 3 steps. Now, let me give you a quick overview of the programmable Trident switches and show you the evolution from Trident 3 on the left to Trident 4. Programmability, together with the integration of key capabilities, provide customers a future-proof platform when they select Broadcom's Trident 3 and Trident 4 based switching hardware. Trident 3 is our 16-nanometer cost-effective programmable switching platform targeted for 25 gig and 100 gig networks with 32 by 100 gig and 48 by 25 gig and 8 by 100 gig ports as popular configurations. Trident 3 supports 32 megabytes of fully shared packet buffer while supporting all the advanced packet transformations and advanced telemetry such as in-band telemetry, flow tracker, buffer statistics monitor, latency monitors, etc. More on this when I talk about telemetry in the next slide. Trident 4 that you see on the right-hand side is our latest 7-nanometer chip, which is now production qualified. Trident 4 supports NPL language compiler and is programmable by customers. It supports 132 megabytes of shared packet buffer with advanced telemetry and is available in 12.8 terabit per second and 8 terabit per second configurations, supporting 400 gig ports. There is nothing that comes close to this in the market in terms of feature set, programmability, telemetry, and bandwidth, all integrated in one piece of silicon. Okay, so here is an example of what Broadcom delivers with Broadview, which are a set of telemetry capabilities offered on our switches. Buffer statistics, for example, that you see here in the list, offers full visibility into packet buffer utilization. In-band telemetry, the next one in the list that you see, offers view into switch latency. As the packet is going through the switch, it can tell you exactly how much latency the packet has encountered. Then it goes ahead and tells you what is the network-wide latency. So packet typically goes from incoming port to an outgoing port somewhere else in the network, and it tells you what is the network-wide latency that particular packet has encountered. And it also tells you what are the different paths that packet has taken through the network. So for example, if you have ECMP, then the packet could take one of the any number of paths that are configured for this multipath based network. And in-band telemetry is going to tell you which of those paths have been selected by the switch as it traverses through the network. And some of these capabilities that you see here are already deployed in large networks. And many are integrated in our customers' solutions undergoing production level test at this very moment. AI and MLOps capabilities are being built based on the Broadview package that Broadcom provides together with the silicon. And Broadcom considers telemetry capabilities as something that should not be compromised upon while delivering bandwidth in mission-critical applications. So in summary, for any large-scale deployments, it is critical to meet many requirements. Open merchant switch silicon-based white boxes meet all the requirements to be adopted worldwide, such as solutions are open and interoperable. There is no hardware software vendor lock-in. Solutions are fully customizable, and because they are programmable, they are also future-proof and hence very cost-effective. We are very happy to be deployed in all market segments, and we offer a full portfolio of switching and routing solutions that meet all your needs. And with that, I pass it on to Mike. Thank you, Mike.
Thank you, Balaji. Super interesting. Really appreciate you taking the time. What I'd like to do now is switch gears. We're going to move from the world of hardware to software. We're going to have Alessandro Barbieri, who's our VP of Product Management that I introduced earlier from Pluribus Networks, take us through innovations in SDN automation. Take it away, Alessandro.
Thank you, Mike. Thank you, Balaji. Mike, I'm trying to get a hold of the... Okay, perfect. I'm controlling the slide. Thank you so much. So I want to start off with a quick baselining of the key requirements driving definitely the development of data center networks and influencing not only Broadcom roadmap, as you have seen, but also Pluribus SDN fabric technology roadmap as well. Balaji spoke about performance, ability to scale, depth of feature in the data plane level, telemetry. Those are all themes which are top of mind for customers, where the role of SDN intercepts sort of the customer requirement is more on the automation, programmability, and the ability to deliver services on top of these intelligent networks with the most or the simplest possible automation construct as possible. So it used to be that we lived in a world where every box, every service is programmed through protocols, but through SDN technologies, SDN construct, it is now possible to treat a large number of devices and manage them as a fleet, where services are deployed uniformly and atomically across an entire fabric. So the role of automation, the role of programmability, simplification, and delivering segmentation services, layer 2, layer 3 VPN kind of services, multi-tenancy on top of a distributed infrastructure is also key requirements where we actually work with many service provider, telco, and large enterprise customer at Pluribus. So today I want to actually spend some time to review quickly the key Pluribus technology construct and give you a sense of our ability to effectively simplify and automate complex services in a multi-site distributed environment. So at Pluribus, what we have developed is effectively a stack, a technology stack. Number one, we have our network operating system, which consists of a set of layer 2, layer 3 VXLAN based standard protocols, right? And it runs on a disaggregated hardware, the same hardware that Balaji described. And Pluribus currently support the Broadcom XGS portfolio of product I mentioned before, the Tridents and the Tomahawk product line more specifically. On top of this infrastructure, Pluribus developed our effectively software-defined control plane, which has two components. The first one is an underlay control plane component. It's the ability to effectively abstract a physical network which you build with your traditional BGP or SPF layer 2 protocols, but abstract it from a physical point of view in such a way that the user doesn't deal with the multiple distributed switches, doesn't have to do box by box programming and automation of underlay services, but rather there's a centralized management view of an entire network, even though the network underneath is fully distributed and fully standard compliant. We call this a distributed controllerless technology, and we're going to see some of the advantages of this technology, this approach, as we go through this presentation. The second dimension of Pluribus SDN control plane or SDN fabric effectively is the ability to fully automate and overlay and all the associated services on top of this overlay. And we're going to touch upon some of these services later on, but mostly in the realm of segmentation and multi-tenancy. The beauty of this overlay is that it's extremely simple to operate, it's extremely automated, and it's highly scalable, because the only scalability limits is actually what is provided by Broadcom Silicon. I want to support 4,000 VRFs, I can use a Trident 3 chipset, for example, and I can scale dramatically the layer 3 segmentation construct. Because we do forwarding based on in the overlay, based on the knowledge of where the different endpoints are in the fabric, and we don't rely necessarily on standard protocols like we do instead in the underlay, it's very simple and very scalable to program the fabric or the switch silicon to forward packets at wire speed and at maximum scale with maximum simplicity in terms of programming these services through the fabric. And last but not least, we developed a tool which we call Unum. It's our platform for management, automation, and analytics, and effectively provides an interface, a portal to manage the fabric and extract and process all the telemetry coming off the Broadcom Silicon, as well as the switching control plane infrastructure of the fabric. Okay, so those are the four elements of the Pluribus sort of architecture stack. How do they really come together? This is a sort of a visual, and how do they come together to deliver different services? At the bottom layer, we have the Advisor 1 network operating system with the layer 3 NOS. This is actually, although it's at the bottom, it's actually, frankly, I think the reason of Pluribus success. And the reason is that because it's standard, because it's open, because we don't change how the network works, but we build SDN on top of a standard infrastructure, we can insert it into any brownfield network. So this is a much overlooked part of the story, but in reality, it's why customer can deploy this technology, because it fits into existing network. So very important technology sort of construct and approach from Pluribus. Then we have the distributed controllerless underlay, right? We abstract this mesh of BGP routers or layer 2 nodes in the network. You control them as a single logical, fully distributed switch. From any point, you can touch any other point. You have full visibility and control. And then on top of this, we build a VXLAN-based overlay infrastructure with a set of automated services, distributed routing, distributed VRFs, bridge domain capabilities, which then we can support multiple encapsulation of traffic, including double tag VLAN traffic on this type of infrastructure. And then, of course, we can deploy policies atomically across the entire fabric. We really use the overlay as a full abstraction of the network, and we can provide in one shot, fully automated, very complex services that can stretch also multiple different geographically separated sites, if you will. And then on top of this infrastructure, clearly we have our GUI management tool, which we call Unum. And then we have our Insight Analytics application. It's really part of the Unum platform. It's really one piece of software, but it's a very different and distinct functionality. It's the ability to process all the telemetry provided by the fabric in terms of packets, flows, state of the different devices through it's capable of ingesting syslog, SNMP, and do correlation across multiple events. It's a very sophisticated piece of software built on an Elasticsearch database. And then on top of this infrastructure, we can deliver multiple services. I call it Metro Ethernet services, the ability to do classic layer 2 Metro Ethernet service provider kind of services, E-line, E3s, the ability to support VLAN aggregation, double tag traffic, to distinguish the different subscribers. All these capabilities are built on top of our overlay. The ability to support cloud and multi-tenancy services through layer 2, layer 3 segmentation. The ability to isolate video and IoT traffic in different segments of the network is a popular use of the Pluribus fabric in a geographically distributed infrastructure like a video surveillance network, for example. Clearly, telco, cloud, and NFVI is an important part of what we do as well. We have numerous telco cloud customers through one of our partnership with Ericsson. So it's an important part of the telco cloud 5G, 4G infrastructure. And then in sort of orange here, there are a couple of services which are sort of adjacent services. They're not core networking, but we've developed an interesting set of capabilities always on top of this overlay to provide lab automation services. This means the ability to effectively build a layer 1 cross-connect, an intelligent patch panel fully software defined to automate lab applications. And then we have packet broker services. This is a new service which we're launching right now, is the ability to actually use these overlay services to replicate and distribute and filter traffic from input ports in the fabric where you're connected to tools and tabs, all the way to tools, security tools, network performance tools that the customer may have deployed. So again, one fabric and multiple services delivered on top of a common infrastructure. And all these services can coexist. You don't have to create a special software or special type of deployment or separate deployment. This can be converged on the same physical infrastructure. Okay, so quickly, how does this fabric technology work? So imagine you have in this simple diagram a couple of switch pairs. We call them cluster. Those are high availability pairs, if you will. They can be interconnected to servers, southbound, or other an access network built of layer 2 switches or even routers. It doesn't really matter. And then we connect to an existing network. Think of it as the spine, the core of your network, and through the protocol of your choice. This is what the customer dictates already as an infrastructure. We are not requiring any changes to that. So these devices can operate with our NOS as traditional network nodes, nothing special, nothing different. What's really interesting, however, is when we create the adaptive cloud fabric control plane, these devices effectively create sort of a federation, and while preserving their distributed nature, ability to run their individual protocols, so that's great for scale, we have the ability to now federate all these devices, and they start sharing state and information. There are actually three properties of this approach. Number one, you can log into any device, and from management point of view and monitoring point of view, what you're dealing with is with a single distributed switch effectively, right? Second, this infrastructure, this fabric, orchestrates on behalf of the customer and automates a number of layer 2 and layer 3 segmentation services built on top of our VXLAN technology, fully accelerated by Broadcom silicon. So, and number three, we have built the ability to simplify the provisioning and automate the deployment of most network objects, which are typical in a service provider or enterprise infrastructure. So you want to create a VRF, you want to create a subnet, you want to create a VLAN, you want to create a policy. Those are single operations which occur atomically across the entire fabric. There's a sophisticated sort of database clustering inspired control plane, which also is capable of providing all the synchronization with rollback capabilities in case there are communication failures or switch failure or device failure within the fabric. So the goal here is to ensure that it's consistently provisioned across the entire fabric, any particular service that the customer wants to deploy. So simplified management, simplified provisioning of services, and then of course an intelligent orchestration of the overlay infrastructure, with full acceleration provided by Broadcom silicon. Again, this is a simple visual which explains some of the concepts I already mentioned. Again, think of every switch as fully distributed. It runs its own standard set of protocols, so it can insert into any network topology. You can deploy this in ring, leaf, spine, across multiple locations, as long as there is an underlay network that can route the management IP of these devices across even a WAN network, you can form a fabric. What is really a fabric? A fabric is a set of connection or TCP sockets. A fabric is really, think of it as a distributed layer 7 application, like a database cluster, if you will, which runs on top of this network. It opens TCP, TLS type of connection to other nodes in the fabric, and now the exchange of endpoint information, exchange of configuration information and state is shared across all the switches. And because of this full visibility of every node, of every other node, a very interesting set of automation capabilities is possible, and I'm going to explain some of them later on when we talk about the overlay, for example. But bottom line, here you have an infrastructure which eliminates 95% plus of the configuration tasks, reduce dramatically human error, and then it ensures consistent programming of this infrastructure. Sometimes customer ask, hey, but can I not do the same with Ansible? Everything can be done with Ansible or other orchestration tools, but what the fabric gives you, which is very hard to replicate, is the consistency layer or the synchronization across all these devices. If you're building your own orchestration system and you don't have this, you need to manage the consistency of the programming across all these devices with all the exceptions. Instead, the fabric allows you to program 40 switches, 50 switches as a single entity, which is actually very powerful and very simplified, also from an orchestration point of view. Next, I want to quickly touch upon the overlay. I'm not going to talk about the services which you can deploy on top of this overlay. They're unicast, IPv4, IPv6, multicast, IPv4, IPv6, services, segmentation, layer 2, layer 3, bridge domain, different types of encapsulation. Is very, very rich. But I really want to talk about why it's simple, why it's scalable, and why it's automated. So, number one, the concept of auto tunnels. All the user have to do in this infrastructure is decide where the virtual tunnel endpoints sit. And because now we have the concept of fabric and every node where every other VTEP is, the full mesh of tunnels is completely automated. So the user configure the VTEPs, the tunnels are automated. Second, as I mentioned before, you want to configure an object, a VLAN, a bridge domain, a VRF, a subnet, a gateway, a policy. Those are single objects that can be managed as if you were deploy them on a single switch effectively. So you don't have to deploy a VLAN across these 20, 30, 40, 50, 60 switches. You deploy an object, the VLAN or your policy, your ACL, as a single object across the entire fabric. So significant reduction of configuration and human error. Then the concept of auto VXLAN. We want to sort of create an experience from a user point of view that is like configuring effectively a standard layer 2 or layer 3 network with the constructs such as VLAN, bridge domain, switch ports, layer 3 VRFs, but we don't want the user to necessarily manage all the details of how these are mapped to different layer 2 and layer 3 VNIs, how the VNIs are mapped to the VTEPs. There's a tremendous level of automation built into the fabric, and the operator only deals with its construct, what really matters, the VLAN, the bridge domain, the layer 2, the layer 3 segment. The entire provisioning of these constructs across an overlay, including mapping on VNIs and VTEPs, is managed by the fabric. We call this capability auto VXLAN. Also very important, because we do forwarding protocol-free in this environment, whether it's unicast or multicast, what we really need to know is where the endpoints are. So we learn endpoints through traditional networking construct and protocols, where when you learn where an endpoint is, we program the hardware to switch and route traffic directly on this on this overlay switch infrastructure. So very efficient. It's conversational based. We don't program everything everywhere. Only if two devices are communicating, we program the hardware, whether it's for routing or for switching or for bridging in the infrastructure. Again, the beauty is simple. It's protocol free. So really, you don't have to become a Cisco certified net engineer to understand what is happening in the fabric or how to provision the service in the fabric. It's extremely simple, extremely automated. How simple and how automated is an example of programming effectively a VRF and a subnet using EVPN on a traditional switch. There are 26 lines just to provision the layer 3 VNI, layer 2 VNI, and then the VRF. If you have 32 switches, of course, 26 times 32. If the animation can proceed. Yeah, there you go. It's coming. Sorry for the lag, but there are 832 lines of code in a traditional infrastructure. Of course, this can be automated through through tools such as I mentioned before, Ansible or anything else, but it's effort, right? And it's complication. And then when something goes wrong, how do you roll back? How do you deal with exception? That's really when the fabric comes in. So not only the fabric helps with that, but the fabric dramatically simplifies. So when I create here effectively a layer 3 service, I create a VLAN, I give it scope fabric. This automatically deploys a service across these 32 switches. This VLAN 101 is atomically provisioned across these switches. I select the qualifier auto VXLAN. In this case, I select the VNI, but I could also let the switch or the OS select the VNI. But in this case, this VNI is automatically attached to all the virtual tunnel endpoint of the fabric. You don't have to go switch by switch and do the VTEP to VNI assignment. Then you do a subnet create, again, scope fabric. So you create this subnet across all the switches, you attach it to the blue VRF, you create an Anycast gateway, and there's nothing else you have to do. From any switch, 2 commands, I say 1 command, but it's really 2 commands. And the simplification here is 2 commands versus the EVPN 832 commands you have seen before. That gives you a sense or a flavor of what I mean by simplification and automation. Another interesting capability is the ability to provide deep, we call it deep slicing. So we have the ability effectively to virtualize this fabric horizontally, not just a switch. We can create a logical switch, which is composed of resources coming from all the switches a part of the fabric. And then we have the ability to provide sort of separate management to different tenants in the fabric. So through REST or CLI, each tenant has access to its own set of VRFs, VLANs, ports, and can provision all the policies of this logically distributed switch. Very interesting capability, very unique. We haven't found in other technologies in the industry. Going really quick through the rest of the slides, the concept of telemetry. We're leveraging a lot of the Broadcom capability that Balaji described, and we also built some interesting capabilities in our software. It's the ability to actually look at every TCP flow in a non-sampled fashion, if you will, on the switch fabric. So you can look at, we can take a look at every packet. That's what Silicon does. The CPU cannot do that, but we can look at every TCP connection, right? The beauty of TCP is that not all packets are created equal. There's the start of a connection, the end of a connection, the resets. Certain packets mean something different in a connection-oriented protocol, and we can actually extract all this telemetry and build sort of a map of who is talking to whom directly into the fabric. So telemetry, very important. So if I were to summarize, what is the differentiation of Pluribus Fabric? Clearly, open networking, it's a differentiation leveraging white box switching and Broadcom silicon. This is a differentiation compared to some vertically integrated vendors, at least. What is unique is having an SDN stack which is fully brownfield interoperable, right? We're not demanding you to change protocols, change architecture, even change topology. You can insert this into any network topology. Very unique how brownfield friendly is a Pluribus SDN fabric stack. This technology works across geo-distributed sites. We have not spent too much time on this, but again, like I said, it's topology independent. You can really deploy this technology across multiple locations and unify the delivery of services across multiple locations. It's controllerless. There are no single point of failure, extremely cost effective even for small deployments. And it's fully automated. We spent time and we saw how simple it's actually to provision even a layer 3 segment across 32 switches compared to a more traditional VPN stack. The telemetry we built into this switch takes advantage not only of the Broadcom capabilities, but we also built some supplemental software capabilities, and a combination of using Broadcom accelerated telemetry and Pluribus additional telemetry for at least TCP traffic is very interesting to customer, very exciting, particularly when coupled with our Insight Analytics application. And last but not least, we're building monitoring services directly as a service of the fabric. Typically, people build separate fabric for monitoring and packet broker, NPB, network packet broker stands. We actually can merge this capability directly into the fabric, or anyway, reuse the same fabric infrastructure to deliver a filtering and replication of traffic for monitoring purposes. This is a customer called Scavolini. It's a mid-market customer. It's a joint customer with Dell. It's a kitchen manufacturer, so it's actually a mission-critical operation because it supports both manufacturing, the manufacturing plants, the data center, and the campus. We built effectively a single distributed fabric to interconnect legacy workloads and legacy switching infrastructure from other vendors. Pluribus effectively has built this distributed fabric between two data centers to support geo-distributed services with distributed routing capabilities. And again, the beauty is that within the fabric, it's protocol free. There's no spanning tree, no routing. The overlay are fully automated, and we interconnect to the Dell, Cisco, and VMware infrastructure already present in the customer infrastructure. So again, there are multiple applications supported. One is definitely IoT. There's actually a segment built on top of this infrastructure just to transport securely and in an isolated fashion IoT services for the company. So this is, again, a simple example of even now a mid-sized market customer now, because this technology is made so simple, they can take advantage of the power of this overlay to actually unify the management and distribution of service across multiple locations. This is my last slide. Mike, do you want to take it from here?
Yeah, I'll wrap it up here, and then we can move on to Q&A. Thank you, Alessandro. That was very enlightening. Great to hear about some of the innovations in network operating systems and SDN for open networking. So the sum of this, just to wrap it up before we roll into Q&A, is public cloud is growing, but 70+% of workloads are in private cloud, on-prem colo data centers. So scaling and automating those data center networks in particular is critical, because we know from the earlier part of the presentation that that's really the thing that's been the most challenging to achieve software-defined data centers to support private cloud. We heard from Broadcom, Balaji at Broadcom. They're delivering open, industry-leading, high-scale and programmable silicon. I'd say at this point that silicon has matched or maybe even exceeded any of the custom ASICs that are developed by some of the vertically integrated incumbents. They have the advantage of mass scale and mass, many customers for that silicon. White box is the fastest growing switching segment from the data center. I'm challenging those incumbents. And we've seen that open networking, which is the bare metal switching plus the operating system, has really matured. It's widely deployed in high-scale production networks. We see it deployed in hyperscalers, obviously, but lots of enterprise, lots of service provider. Pluribus is deployed in over 75 tier 1 mobile operators today. So this software and these solutions are really being taken to task and being hardened out there in production networks. And powerful SDN automation can be deployed very cost effectively and out of the box to simplify these data center networks to achieve that software-defined data center, to provide cloud-like services in the on-prem colo-based or hosted environments. So with that, let me move into the Q&A section. And let me just get my questions opened here. Okay. So the first one here, I think this is probably for Alessandro. Based on your slide, I assume Pluribus does not support EVPN. Is that correct? Alessandro,
Yeah.
you want to take that?
Yes. No. The answer is Pluribus is not against EVPN at all. EVPN is the tool to guarantee interoperability, right? So for interoperability purposes, Pluribus is working on supporting EVPN with FRR 7.2. This is a capability which will be released in the second part of this year, but it's definitely on a roadmap. It's been requested by many customers. Within the fabric, the overlay can be done more intelligently in a much more automated and simple way than using EVPN. But to interoperate in a multi-vendor environment, we will extend our fabric to actually speak EVPN to third party. So EVPN is definitely part of our roadmap and plans.
Okay, great, thanks. This one looks like it's for Balaji. Actually, there's a couple of questions that could be combined here. Does Broadcom support P4? What have you seen in terms of adoption of P4? And then a related question: how programmable is NPL? How does it compare with P4? So I think I can combine those, Balaji, if you want to take a crack at that.
Yeah, absolutely. No, thank you. I think it's a great question, and we get asked that question many times, and I'll be happy to answer that now. So, at Broadcom, we have spent considerable time evaluating P4. Okay, for a long time, and we have seen that P4 falls significantly short in many areas, such as P4 only has basic constructs such as parser, single lookup tables, and editor, which are not enough to realize practical high bandwidth products needed in the market. Okay, you can already see that Barefoot was barely there with 6.4 terabit per second switch, 20 megabytes of packet buffer, and we were at 12.8 terabit per second switch with 64 megabytes of packet buffer in production, very quickly. So you can easily see that the P4 constructs didn't really help realize the silicon. And then industrial strength switching pipelines, such as what we offer, have a lot more capabilities. And we have a lot of advanced constructs, such as multi-lookup tables, table-independent actions, etc. And efficiency of implementation is also very critical to offer 12.8 terabit per second and beyond silicon that fit within the power and cost budget. And these are not provided by P4. So let me talk about NPL a little bit here. So we have addressed these in our NPL programming language, and NPL is open. You can go to nplang.org and look at the spec of that. So that's one thing. The second aspect is that we have actually supported NPL in multiple product lines. So we have it supported on Trident 4, which is, as I said before, production qualified. And we also have it on the Jericho 2 product, which is also in production. And we address a very large customer base in the enterprise, telco, and data center space. So I think we have covered really well with NPL. And when it comes to the other question you had in terms of what is the adoption of P4, we see, of course, there are a lot of science experiments with that. We see a very, very little in terms of what customers have been able to really do in a practical network. But what we are able to see in our case is that NPL has been used in both Trident 4 and Jericho 2 and been able to instrument tremendous amount of functionality in our silicon. So we are pretty happy with where we are with NPL.
Great, thanks, Balaji. Here's one, Alessandro, I think this will be for you. What is the value to terminating VXLAN overlay on switches? It seems like a lot of folks are terminating on compute. If you want to take a crack at communicating the value piece of that.
Yeah, it's a slightly different approach than terminating tunnels on servers. I think the main difference here is the ability to use Broadcom silicon to offload the server from having to run and burn, let's say, precious CPU cycles, from having to run networking functions and services on top of an encapsulated overlay. So really, the value for many customers is you can keep the server as simple as possible, dealing with VLAN and IP addresses without the need of having a complex OVS infrastructure to run overlay with associated orchestration and operational cost. You can let the network really run the segmentation services for you and do this with full acceleration of Broadcom silicon, which is something the server cannot match at scale.
Great. I think I'll add to that. The other thing I've seen is, I'll go back to this slide, is the use of the extending the overlay out of the data center to access switches like the video surveillance aggregation or wiring closet aggregation, where you can do network segmentation throughout the network and feed in inbound or ingress traffic that is not coming from a server. It's coming from another, an access switch or some kind of IoT gateway that needs a slice to feed into, and it lets that extension of network segmentation kind of expand outside the data center.
How much is that?
Let's see, we have probably time maybe for two more. Okay, here's one from Ragava. Building a fabric, is this only for greenfield implementations or can be implemented in brownfield? If yes, for brownfield, how does the existing configurations, ACLs, routes be discovered which are already in place? That's probably for you, Alessandro.
Sorry, Mike, can you repeat the question?
Fundamentally, it's is building a fabric greenfield only or brownfield? And if for brownfield, what is the process for discovering existing configurations that are already in place or dealing with that?
Yeah, so in a brownfield environment, a Pluribus device operates as effectively a brownfield switch or a legacy switch or router, right? It runs a set of layer 2 and layer 3 protocols. It becomes like a node of the network from the perspective of a third-party device already deployed. So it really speaks a friendly language and does not require any changes to the existing network. The way we effectively discover the configuration is by using layer 2 and layer 3 protocols, right? We integrate with legacy networks through standard legacy protocols, so we can discover the state of the network through that. And then within the fabric is when we have our SDN control plane for simplification and automation.
Okay, great. All right, we're at the top of the hour, but I want to squeeze one more question in and then we'll wrap it up. From Faisal, when we talk about data center automation, how big is the scale you are taking into account? I guess that's you again, Alessandro. You want to take a crack at that?
Yeah, so scale in terms of number of nodes or number of switches, maybe that's a dimension of scale. We talk about scaling this fabric to 256, 512 nodes from where we are today. So I think we believe this is achievable. And then there's another dimension of scale, which is sort of the number of, let's say, layer 3 segments, for example, layer 2 segments. This is purely in our environment a function of the Broadcom silicon you choose. We support the XGS portfolio, I believe. We can support things such as 4,000 layer 3 segments. Bridge domain, there are 32,000 bridge domain per switch pair. So that there's a tremendous actually scale which is defined by the hardware in terms of delivering layer 2 and layer 3 services on top of the overlay.
Okay, great. Faisal, we can also send you an email to clarify, make sure we understand what dimension of scale, but you know, we have a deployment underway that's a 64 node fabric, and then we can also federate together fabrics, so you can have multiple fabrics that are federated together, so the scale is pretty significant. All right, there's a number of questions we didn't get to, but we can address those in email. I wanted to thank our two presenters, Balaji from Broadcom and Alessandro from Pluribus Networks. Thanks for taking the time to go over this interesting information, and thank you for all the attendees from around the world who watched us today. Please stay safe and healthy out there. Thank you.
Thank you.
Thank you.